Hello! This video gives an overview of the work by a team of researchers at Northern Illinois University, the University of Illinois at Chicago, and Northeastern University, using funding from a Sustaining Illinois grant from the Illinois Innovation Network. We held a series of collaborative workshops with stakeholders in spring 2021 to create a shared representation of the integrated urban-rural system in Northern Illinois. We first met with stakeholders in smaller groups organized by sector, energy, water, and food, to jointly draw causal links across important factors in each sector in an online collaborative platform called Miro. Next, we held larger workshops with the participants from all sectors separated into two breakout groups to review the synthesis of each sector diagram, finding connections among them, identifying any missing links, and discussing lever points for action. In these charts, the boxes show names of variables within a system. The variables can increase or decrease over time. The legend at the top shows the color scheme for the variables: yellow for energy, green for food, blue for water. Other colors, like pink, are mostly external to the system, but influence it. The arrows connecting variables indicate a relationship between the items. There are black arrows with a plus sign and red arrows with a minus sign to indicate if the connections between the variables is positive or negative. This doesn't mean good or bad, but rather whether the variables change in the same direction, which is positive, or in opposite directions, which is negative. For example, more rural runoff leads to more water pollution, and the inverse is true. Less runoff leads to less pollution, so this is a positive relationship. It's a negative relationship if the variables change in opposite directions. For example, as water pollution increases, water quality decreases. Dashed arrows and corresponding variables indicate items discussed by only one of the two breakout groups in the final meeting. The legend indicates which group proposed that connection by the size of the dashed lines. Our discussions and analysis of the diagrams have allowed us to isolate key causal dynamics within and across the three domains. In the energy system, activism, including infrastructure to support it, is key to demonstrating the will for change and to pressuring elected leaders and public agency officials to make policy and management changes. New technologies are also key to changing the system. Technology and advocacy is not enough, however. It is also necessary to create the right institutional frameworks to support private and public investments. Connections to other systems are important here. For example, the connection from biofuel production to land use in the food system can increase demand for commodity crops at the expense of non-commodity crops. In the water system, development in all forms, economic development, urbanization, reuse of brownfields, is crucial because there are both high fixed costs for maintaining existing infrastructure and huge demands for new infrastructure. Development can increase the capacities for local entities to pay for development and maintenance of infrastructure. The connection from investment in clean technologies in the energy system to wastewater treatment presents opportunities for water treatment innovation, since conventional treatment is so energy intensive. Wastewater treatment can also create high-quality fertilizers for use in the food system. In the food system, agricultural subsidies drive the production of commodity crops, encouraging large farming land holdings and concentrated economic power, which in turn supports continued subsidies. Prices and production impact the demand and consumption of different types of food, both healthy food, such as vegetables, and unhealthy food derived from commodity crops. When the production of commodity crops is high, their prices remain low relative to produce. As prices go up, demand tends to go down. So if produce is more expensive than corn-derived foods, then demand will remain higher for unhealthy foods. Less consumption of produce and other nutritionally dense foods leads to worse health outcomes. These diagrams lend themselves to more systematic and quantitative analysis for additional insights and richer stories about the connections between and across urban-rural systems. This will be the focus of the future work of our team. In the meantime, we encourage you to explore the diagrams on Miro and let us know if you have any questions, comments, or suggestions. The main things you will need to do to navigate around the map are to pan and zoom. To pan, make sure you have the hand icon selected, and then press down the mouse button. If you see an arrow instead of a hand, click on the arrow on this toolbar on the left. To zoom, you can use the plus and minus keys or the plus and minus buttons at the bottom of the screen. Boxes with arrows represent variables that can be expanded into separate submodels. To see the submodel, click on the arrow and the view will zoom to the right. Click on the arrow within a subdiagram to zoom back to the main one. Once again, thank you.